you are losing a lot of value if you can't make it, there's an enormous return on investment for any company that's paying a developer a reasonable developer wage and sends their developers here. I can't tell you how big of a mistake it is not to send someone to CppCon.
Hey everybody, and welcome. So today I'm going to talk about the intrinsic built-in constant p. So to explain what I mean, let's start with an example problem. So here we have a program that checks to see if you can get the value from an event, and another function that prints the value to the console. But as we can see, this program is not valid. We get a substitution failure in the print value because the event type that we pass in doesn't have a value. How can we fix this? To answer that, we need to understand a language feature called constexpr if statements introduced in C++17. So one thing to know about them is that the value of the condition must be a constant expression. If it's not, that's a compilation error. And then secondly, inside of a template, the discarded statement is not instantiated, which is pretty mind-blowing. What this means for us is that we can change our check to be an if constexpr statement, and now the program compiles. To make sure that it works properly, we can pass in an event that has a value, and we can see that the program properly prints out the value. But if constexpr doesn't solve everything. So let's say that we have a function that checks the value is equal to a particular constant. And then if that's true, then we print the value. We can't just pass that to if constexpr. In that case, we get the error from the first bullet where it's not a constant expression. So my question is, can we have both? Is there a way to express this such that it's an if constexpr when it needs to be? Otherwise, it's a runtime if. And so we have this intrinsic called built-in constant p. It determines if the value is known to be constant at compile time. The argument of the function is the value to test. Returns 1 if the argument is a compile time constant, otherwise returns 0. So this is almost exactly what we need. So we can rewrite the function by first checking if the guard can be invoked at compile time, and if it can, then we pass it to an if constexpr, which will prevent the substitution failure in the action. Otherwise, if we can't invoke it at compile time, then we pass it to an if statement, and then the action will always be instantiated. But it allows a non-constant expression as a guard. So let's look at this in a more complex example, interstate machines. So this example uses a library called boostxsml, written by Chris Jusiak, a great programmer. In this example, we have a state machine that takes a generic type T as an event, and then checks to see if it has a value, and if the value is equal to the constant 42, and if both of those are satisfied, then it prints the value. But unfortunately, like the first example, it has substitution failure. So how can we fix this? Well, in the implementation of boostxsml, there's an overloaded AND operator for the guards. It takes the left-hand side function and the right-hand side function, and it returns a new function that simply invokes each of them on the argument and returns the compound AND. And this is the crux of the issue, is that it always invokes the left-hand side and the right-hand side at runtime. So we can redefine this using our built-in constant p, check if the left-hand side can be evaluated at compile time. If so, we evaluate it at compile time and then check the right-hand side if it's true. Otherwise, we immediately return false, so we avoid the substitution failure on the right-hand side. Otherwise, we fall back to just invoking both of them at runtime. So that was my demonstration. Thanks.